grade. I hope everyone is doing well. Welcome to my kitchens for our first lab, and today we're going to talk about electricity, which is a form of energy. But I want to refresh your memory on what we did. It's probably been about 2.5 months now on what we did before, because we looked at different kinds of energy, which were potential and kinetic energy. So energy is just the ability to do work, how things change and move. So last time we talked about potential energy, which is stored energy. And we talked about how if something is just sitting there, it doesn't have energy. But if you move it, then it has potential energy, which is stored energy. So if you move it just a little bit here, it has a little bit of potential energy, whereas if you move it up higher, it has more potential energy. And that potential energy can change into kinetic or moving energy if you drop it. Okay, and remember we took our marbles and we rolled it down the tubes, and we saw that when we had a little bit of potential energy, it didn't roll as far because it didn't have as much, it didn't convert to as much kinetic energy compared to if we gave it more potential energy and raised it up farther. We also saw that energy can be transferred from one thing to another. So if this marble with this potential energy turns into kinetic energy, can then hit the second marble and transfer that energy to the second marble. All right, so today we are going to talk about electricity. Okay, so let's go over what kind of energy electricity is. Okay, and the first examples I'm going to give is current electricity, which is moving electricity. So I just wanted to go over matter, which is everything. The air we breathe, the liquids we drink, the solids. And matter is made up of several very, very small things that we can't see with our eyes. And one of these really small things is called an electron. And an electron is a negatively charged particle within the matter, okay? Now, current electricity is moving electrons. So these moving electrons create this current, and the current is what can do work on something. And that something is what we call a load. So it can create sound, it can create electricity or light, it can turn on a light, it can turn on a motor, make things move that way. Okay? So electricity is just the movement of the electrons. And today we are going to use alkaline batteries. And I think that you guys are pretty familiar with batteries. So the alkaline battery has a negative end called the anode and a positive end called the cathode. I just wanted to remind you guys that opposites attract and like repel. So the electrons that are created by a salt solution inside of the battery, they come out the negative side, the anode, and they travel towards the positive side because the negative is attracted to the positive. And then that's how we get moving electrons to produce our current. And these electrons can move through metal. And the most widely used metal that's used, and we will be using in our wires today, is copper metal. So what you can do then is you can create circuits of these moving electrons, okay, which is your current. And you can, I have a simple circuit set up right here. And there are closed circuits. So a closed circuit is just when everything is connected. And I know it's kind of weak, but you can see that the light bulb is going on. So it's a closed circuit. It just means that the electrons are moving. Okay, they're creating the current and they're doing work on this load, which is the light bulb. And the amount of current that you are producing will affect how much work can be done on your load. So for example, I have 1D battery, and you can see here that my bulb gets lit, okay, by the work, but it's not very bright. Whereas if I go and change it from 1V battery and I'm going to give it more current, okay, then look what happens to my bulb. There. It is much brighter, okay, because I have more current. So a closed circuit is where the electrons can flow and do work. An open circuit is when there's something not connected and the electrons can't flow. Okay, that's all the difference there is. Okay, and you can add a switch, like when you walk into a room, you turn on your switch to get the light on in the room and then turn it off when you leave. And see, now I have a closed circuit. I remove the switch, undo the switch, and now I have an open circuit so the current can't flow. Then I can turn on my switch, get flowing electricity. Now this is a series circuit, so it's just wherever I undo my connections, okay, at whatever stage, I turn off the current, so I'm not getting work on a load. You can have a parallel circuit, and this is great because you can turn off one current but keep another current on. So like when you're at home, you want to be able to turn on lights in one room but not all the rooms in your house. So that is why a parallel circuit is important. What I can do is put another light. So I have 2 rooms in my house that I want to light up, and sometimes I want them on at the same time, like now. And this is called a parallel because you can see, okay, that the wires are parallel to each other. And sometimes I want to just turn on one light bulb. So if I want to keep that one on, I'll turn that one off, okay? Or I can turn this one off and keep that one on, depending on which room I'm in. So parallel circuits are really important. Have you ever taken off a hat and noticed that your hair is standing up? Or you were wearing socks and you walked across the carpet and touched someone and zapped them? Well, if you've done that, and I'm sure you all have, you've experienced static electricity. And static electricity is just the buildup of charges. So when we were talking about current electricity, I was telling you about matter and the small particles that make up matter. One's called an electron. It's negatively charged. And there's also a positively charged particle called a proton. So what is happening with your hair is normally neutral. So the positives balance the negatives, and so it's overall a neutral charge. However, if you do something like put on a wool hat, or what a lot of you like to do is rub a rubber balloon to your hair, you are going from your hair being neutral, so positive and negatives kind of distributed equally throughout your hair, to rubbing off some of the electrons from the balloon onto your hair. And so what happens is when you do that, your hair is overall negatively charged. And as you guys remember, right, opposites attract, like repel. So if you have more negative on your hair wants to repel each other, and the only way it can do that is for it to stand up and try to get as far away from each other as it can. Okay, so now these electrons, there are some materials that like to give up the electrons and some materials that like to take the electrons. So for the rubber balloon, the balloon likes to give up the electrons to your hair. Okay, so another thing that I wanted to go over with lightning. So this is an example of you rubbing your socks on the carpet and then touching like a metal door or even another person. So what's happening is during storms, there are little ice pieces up in clouds, and those ice pieces, ice chunks, are like hitting each other and creating charges. And when these charges get what's called polarized, which means most of one kind of charge goes to one part of the cloud and another charge goes to the other part of the cloud. So when it becomes polarized and there's negative charges build up on the bottom of the cloud, it can be attracted to positive charges build up on the ground, and then those electrons can travel through the air. So the pathway would be the air to the ground, and zap, that's how lightning works. Now you guys are going to try several different things. The rubber balloon works really well, as you all know. You rub it on your hair. You can try to pick up different items. You can try to pick up, I don't know if you have Rice Krispies, or even what's easier is little pieces of tissue. So that is fun. And sometimes you have to kind of rub it a bit on your hair. There. All right. So another thing you can try to use as well is a plastic comb, and rubbing it through your hair, and try to use the plastic comb. Now I don't know if the plastic comb works for a tin can, but you can rub the balloon on your hair and try to attract, pull, or push a tin can and make it roll. So that's fun. And then the last thing I think would be fun for you guys is if you take the balloon, rub it. I think you have to rub it pretty well. Go over to your sink, turn it on really low, and then try to attract the water. It's called bending water. Okay, so I hope you guys had fun learning about static and current electricity, and have a great day.